Have you ever wondered what generative AI is? Well, let's unravel this mystery. Generative AI is a fascinating subset of artificial intelligence. But what sets it apart? It's the ability to create, to generate new content. Picture a computer, not just processing data, but actually learning from it and creating something brand new. Sounds almost artistic, doesn't it? Now you might be wondering, what kind of content can generative AI create? The answer is quite diverse. It can generate images, compose music, or even write text. For instance, models like GPT-3 or DALL-E are making waves in the AI realm by generating human-like text and images respectively. They learn from a vast set of data, understanding patterns and nuances, and then they create. So, generative AI is just like an artist who learns from observing the world and then creates something new. Astounding, isn't it? Wait till you hear more about how it works. Now, you may be asking, how does generative AI work? Well, it's a fascinating process. Generative AI operates on the principle of learning patterns and structures in data. It's like a virtual artist, observing an array of artworks to understand the essence of art and then creating its own masterpiece. To do this, the AI is trained using a large volume of data. The AI scrutinizes this data, identifies patterns, and learns how to reproduce similar content. It's not just copying, it's learning, understanding, and generating. There are different models used in generative AI. The popular ones include generative adversarial networks, or GANs, which pit two AI models against each other to produce new data. Then there are variational autoencoders, VAEs, which work by compressing data into a simpler form and recreating it. And let's not forget transformer models, which are particularly good at understanding sequential data, like language. In essence, generative AI learns from existing data to create new original content. But how do we implement generative AI using Python? Well, Python is a go-to language for many AI enthusiasts due to its simplicity and wide range of libraries. To implement generative AI, we often use libraries such as TensorFlow and PyTorch. These libraries are like toolkits, stocked with pre-built modules and functions that make the process of building, training, and using generative AI models easier and more efficient. Let's take TensorFlow, for instance. It's an open-source library developed by Google Brain that provides a range of tools for machine learning and deep learning. With TensorFlow, you can create generative AI models like generative adversarial networks, or GANs, which are popular for creating new images or enhancing existing ones. On the other hand, PyTorch, developed by Facebook's AI Research Lab, offers dynamic computational graphing and a high-level API for building deep learning models. With Python and the right libraries, we can tap into the power of generative AI. So where is generative AI used in the real world? You might be surprised by the diversity of applications. Let's start with the gaming industry. Developers are using generative AI to create highly realistic and immersive environments. This technology can generate intricate landscapes, bustling cityscapes, and even alien worlds. The results are so lifelike, you'd think you've stepped into a different reality. Now, let's switch gears and head into the realm of pharmaceutical research. Scientists are using generative AI to develop new drug molecules. This process, which traditionally takes years of trial and error, can now be expedited with AI, potentially leading to breakthroughs in treatments and cures. But it's not all science and technology. Generative AI is also making waves in the world of art, creating unique and intriguing pieces. It's even being used in journalism to write news articles. From gaming to healthcare, generative AI is revolutionizing industries. To sum up, we've embarked on an enlightening journey through the realms of generative AI. We've unearthed its core principles, how it operates, and its application using Python. We've also seen the transformative power of generative AI in various use cases. Models like GPT-3, DALL-E, and StyleGAN have been leading the charge, demonstrating impressive capabilities. It's like having a digital artist, a writer, and a designer all rolled into one. And the beauty of it all? It's powered by lines of Python code, making it accessible to anyone with the drive to learn. Generative AI is indeed a revolution in the making. Its potential is vast, from creating art and music to designing new products and even simulating realistic human behavior. As we continue to explore its possibilities and refine its capabilities, we're essentially shaping the future. As we continue to innovate and push the boundaries of what's possible, who knows what the future holds for generative AI?